All right. So remember to graph these on your number line as well. I just put, when it's a one number answer, I just put the number in the middle and put one to the left and right of it. Open circle or solid dot. Open, not including it, because it was just less than. And then less than is going towards the -7. Those numbers are less than -6. All right. So some of you didn't, do your number line graph. So make sure you do that tomorrow to get full credit. Okay. That's a pretty easy one. Any questions? All right. Number 2. Distribute first. And then it's really similar to that first one. All right. So -3x minus 6, 5x plus 7. I'm just going to continue to keep my x on the left. I'm going to do what I did last time, 2 steps at once. So I get -8x less than 13. Divide by -8. So I got to remember to switch my inequality symbol again. Which gives me x is greater than, -13/8. Okay? And that's, between -1 and -2. Okay? So I would probably just do this, put -13/8 here, and then put -2 here and -1 here, showing that it's between those two. Again, it's just greater than, so it's a circle, and greater than would be going towards the -1. Okay. If you want to use the decimal, that's fine. If that helps you know where to put it on the number line, you can do that. So -13 divided by 8. -1.625. So if you want to use that, you can. If it's easier for you to write the decimals and where to put them. All right. We good on the 2 basic inequalities? Okay. Now we got the 2 compound inequalities, which is 2 of them. All right, and this one now you could write it as 2 separate, or you can leave it like that. I just prefer to leave it like that and just know I have to get x alone, so I'm going to add 1 first, but I got to remember to add it to both ends then. So I get 11. 3x and 1, and then divide by 3, so you do that to both ends as well. So you get 11/3 greater than or equal to x greater than or equal to 1/3. Okay? So when it's greater, it's an OR problem, right? Isn't that what we said? Okay. Greater, all right? So when we graph those, it's a union, right? So just, you put the 2 graphs together. When it's less than, it's an and. Just add a D on than. So less than, it's an intersection. So you graph where they overlap. Okay, so this one's a greater, so it's an or. We're going to just put the 2 graphs together. Okay, so when I do my number line, 1/3 is between 0 and 1, And 11/3 is between 3 and 4, right? What's that, 3 2/3? Okay, so 11/3 would be here. Solid dot because of the equal to. 1/3 would be here. Solid dot because of the equal to. All right. So this is saying 11/3 is bigger than x. So 11/3 is bigger than the numbers to its left. So that would be going this way. Okay. This is always saying x is bigger than 1/3. So the numbers bigger than 1/3 are this way. Okay, if I put those two together, what am I covering? Everything, right? It's an or, so I'm just putting them together. So I'm covering everything. So basically, it's an all real number. Anything works because it works for one or the other. Okay? If it was an and, I would see where they overlap. I would have just covered the in-between part. That makes sense? So if those were less thans instead, and they went towards each other, then they'd overlap. If it was a less than and they go opposite direction, if it was an and they went opposite directions, nothing overlaps, so there'd be no solution. Okay? When it's an and, it's got to work for both equations or inequalities. When it's an or, it can work for one or the other. Okay? So just pay attention to those little details. All right, any questions on that? Okay. Number 4, another compound one. This is another or. I think I wrote or between, didn't I? Yeah. So we got 2x minus 7 less than or equal to 15, or 3x minus 1 less than or equal to 5. So do each problem separate, and then we'll graph. Put the two graphs together. So this is x is less than or equal to 11, or x is less than or equal to 2. Okay, so let's see what those look like and then put them together. 11 would be down here. 2 would be down here. Less than or equal to, so solid. All right, so less than or equal to 11 is this way. Less than or equal to 2 is this way. When I put those together, what is it? From the 11 to the left forever, right? Okay? Since if I had written and in between them, then I would have just gone from the 2 to the 11. Okay? That makes sense? So, just pay attention to those little details, ands and ors. Okay? All right, number 5 was an absolute value one. So remember, those have two inequalities. Okay? Your original, and since it's greater, another or, and then again 2x minus 1, that doesn't change. Don't change what's inside the absolute value sign. Okay? Then all you change is the inequality symbol, turn it around, and make the 4 negative. Okay? So there's my two inequalities I have to write. So then I add 1 and divide by 2 for both. So 1's 5 halves, or you could write 2 1/2 if you want. Or negative 3 halves, which is negative 1 1/2. Right? So putting those in the right spot, the negative 1 1/2 would be the one on the left. the 2.5 is the one on the right. Now equal to, so we got circles at both. All right, so greater than 5/2 would be that way, and less than negative 1.5 that way. That's what usually happens with the ors. They usually go opposite directions like that. Okay. Questions? All right. Number 6, another absolute value. This time it's less than or equal to, so it's an and when we write both of them. So we got 3x minus 12 less than or equal to 12 and 3x minus 12 greater than or equal to negative 12. So remember, switch the inequality symbol, make your number a negative. And we'll do negative 12 plus 12 is 0. 0 divided by 3 is what? 0. That's an answer, right? That's not a no solution. You can divide 0 by anything and get 0. You just can't divide by 0. That's when you get that no solution stuff. Add 12 and divide by 3 also here. Okay. So 0 would be down here. 8 would be up here. And solid dots, because of the equal to, says less than or equal to 8, so I'd be going this way. Greater than or equal to that way. When it's an and, I see where they overlap. Where they're overlapping is in between those two, right? From here to here is where they overlap. Okay? Questions on 6. Ands overlap, ors put together. All right, 7 and 8 are quadratic formulas. Not formulas, but quadratic inequalities. You could use a quadratic formula if you don't like factoring, but I would factor to be quicker. What's the first thing I always do when we factor? Look for a GCF. Very good. What is a GCF? X. So pull that X out. X squared divided by X is X. 7x divided by X is 7. So set them equal to 0. So X equals 0. And X plus 7 equals 0. So my critical values are 0 and negative 7. All right. So when I graph it, negative 7's here, 0's up here. Okay? Since it's no equal to, we'll have circles. And this is where we have to pick different numbers. Okay? So we're going to pick negative 8. I'm going to use negative 1. That should be easy to work with. And I'm going to use positive 1. Again, you can pick any numbers you want, though. Just make sure they're in that section. All right? So negative 8 squared is 64. And 7 times negative 8 is negative 56, which would be, what, 8? Is 8 greater than 0? No. So then I put negative 1 squared would be 1. And 7 times negative 1 is negative 7. That equals negative 6. Is that less than 0 or greater than 0? No, right? 1 squared is 1, plus 7 times 7 is 8. Is that greater than 0? Yeah. So it would. Did I do something wrong?
The other 8 is also greater than 0.
Oh, yeah. I said negative. Why did I put negative 8? Oh, I was looking at that. Right. 8 is greater than 0. Sorry. Duh. My bad. Yeah. So it goes opposite directions. Thanks for helping me out, Ryan. I said 8, but I was looking at -8 for some reason. All right. Other questions? I'm not trying to confuse you. Number 8, again, we haven't done using the quadratic formula, but you could. But again, you guys are pretty good at factoring. So I would factor. What factors of 6 add up to 5? 3 and 2, right? To get positive 6. Right? If it was a -6, then we'd have to use positive 6 and -1, right? But since it's positive 6 and a positive 5, we need a positive 3 and a positive 2. So my critical values are -3 and -2 for my graph. Okay? So I got -3 here and -2 here. So I'm going to use 0 and -4. What should I use in between? Yeah, I would use -2.5. Halfway. If you got numbers like that, they're right next to each other. Okay. What if I had like -2/3 and a -1/3? Let's say were my two critical values. What's in between them? How do I figure that out? Change the denominator to a common denominator, right? What is the common denominator? 6, right? So I'd multiply 3 by 2. So what's 2 times 2? So -4. 3 times 2 again. What's 1 times 2? So what should you use? -3/6 or -1/2, right? So if that happens, you get, if you get decimals or fractions that are really close, try to figure out a number between them. Okay, if that happens to you. All right, going back to this, -4 squared is 16. 5 times -4 is -20, and then plus 6, which would be -4 plus 6, positive 2. Does that work? No. Let's look at the 0. Usually, if this end doesn't work, that end doesn't work. All right, and if that end doesn't work, what's it going to mean to me? It's going to be in the middle, right? So then maybe I don't have to worry about putting that in the calculator. But you can put it in the calculator, right? But if I get 0 squared, I get 0. 5 times 0 is 0. Plus 6 would be 6. Is that less than 0? No. All right. So it's going to be open circles because it was just less than. And that's going to work. All right. I would put it in my calculator just to make sure I didn't make any mistakes. My calculator would show up. There it is. So I'd put -2.5 in parentheses squared plus 5 times -2.5 and then plus 6. I got a negative number. Is that less than 0? Yeah. So it does work. Okay? So if you get those decimals or some fractions, you can use your calculator. It's okay. All right. So those are the quadratics. Last two are the rational ones. Probably the ones that give you the most trouble. Just take your time. All right. So I got x minus 5 over x plus 8 greater than or equal to 3. All right. So we want it to be a single fraction and 0 on the other side. Okay. If it's already done for us, then we don't have to do that work. But this wasn't done for us. So we're going to have to subtract 3, both sides. We get this. Right? That's what we got right now. And then I'll have 0, what I want there. But in order to subtract this fraction from that, I got to get common denominator. So there's only one denominator, x plus 8. So I'm multiplying the 1 by x plus 8. That means I got to multiply the 3 by x plus 8. So I have a common denominator. Okay? So that's the kind of tricky part, if there's any tricky part for you. So we got x plus 8 in the bottom. We got our 0 on the right, like we want. But I got to distribute this 3 first. So 3 times x is 3x. 3 times 8 is 24. So I got 1x minus 3x gives me a negative 2x. And negative 5 minus 24 is a negative 29. Now I can figure out my critical values. My critical value for the denominator is negative 8. Here I'm going to have to add 29 and divide by negative 2, which is negative 29 halves, or it's negative 14 and a half. Okay, so then I can do my graph. So negative 14 and a half's down here, and negative 8's here. So I'm going to pick 0 on this end. I'm probably going to make negative 10 here, probably is what I would pick, and negative 15 here. And then I go to the original problem. Negative 15 minus 5 is negative 20, and negative 15 plus 8 is negative 7. That's 2 point something, positive 2 point something. Is that greater than 3? No. Negative 10 minus 5 is a negative 15. And negative 10 plus 8 is a negative 2. That's a positive 7.5. Is that bigger than 3? Yeah. Oh, I got to do my, at the 14.5, that's the top, right? I can make it solid. But remember, the negative 8, the denominator is always a circle. All right, that worked, so connect them. 0 minus 5 is negative 5. 0 plus 8 is 8. Is negative 5/8 bigger than 3? No. Questions? All right. Last one. Another fraction one. Okay, so I'm doing the same thing. I'm subtracting 4. So I got to multiply top and bottom by 2x plus 7 to get my common denominator going. We good on that step? What if that 4 was negative when I brought it over? What would I have? What would this be? That'd be addition, right? Okay, so if I have a negative over here and bring it over, remember, it's addition. But this one's a subtraction again. So I distribute. I got 8x plus 28. So when I subtract them, I got 1x minus 8x is negative 7x. And nothing minus 28 is negative 28. All right, so I set those equal to 0 to get my critical values. So I get negative 7x is 28. Divided by negative 7, I get negative 4. And for the 2x plus 7, I subtract 7. And divide by 2. That's a negative 3.5. So I got negative 4 and a negative 3.5. So I got to find the number between those two for the middle part. Negative 4 would be here. Negative 3.5 is here. All right. The negative 3.5 was the bottom. So that's a circle. The -4 was the top, and it had the equal to, so that's solid. If the equal to wasn't there, they'd both be circles. All right, so I'm going to use -5. What do you want to use in here? Yeah, I would use -3.75. Just cut it in half. And here I would just use 0. It'd be easy to work with. All right. So the original problem, I'll put it underneath so we can see x over x 2x plus 7. All right. So -5 over -10 plus 7 would be -3, would be 5/3, which is 1 2/3. Is that greater than 4? No, so I wouldn't go towards that direction. -3.75 in the top, and then 2 times -3.75 plus 7. Just make sure I get this right. -0.5. Okay, so -3.75 divided by -0.5. I get 7.5. Is that bigger than 4? So that worked. Okay. When I put 0 in, I got 0 up top. So what's that going to give me? 0, right? Is 0 bigger than 4? No, that's why we use 0 because it's so easy. Okay? Questions? Do we know what to expect for tomorrow? Okay. Thanks for your attention. Been doing a good job. Continue. Look good, feel good? You are good. You guys have been very good.